So my addition is to make sure that you lose energy or to make sure that you lose money, yes, is the correct way. But so that means temperature setting is important and easy. On the other hand, the same oven can really work much more efficient. Ovens, we mainly make air recirculation or air preheating in the ovens. Again, an economizer, this time we call it recuperator. You just use the exhaust to preheat the oven again. It was your money, now you take your money back. Or in the oven, there is hot air and just throwing out, instead of throwing out them all, take some part back to the oven because it was heated with energy, and why I don't need to heat everything again, I can take it back. As a real example, in a paper mill, so only this one is wrong, I have to tell you, this is tons per hours. Sorry for that. So in this paper mill, you know, the paper comes as a pulp and then gets dried, and at the end we have the paper. These are how the paper mills are working. And there are large ovens which are not called as ovens, they are called as paper mills, and it's a very strong thermal process. So in the previous version, they were just sucking cold air and then heating it with steam. What was the problem? You have to increase the temperature of air also instead of making the drying. Afterwards you could make the drying. And they were using continuously lots of steam. Today, it's still in installation process. The job we have made them together there is they want to save energy and increase the production. Today they are using the same energy, but now they are producing almost 50% more. What have we done? Their hot air with humidity, it was just thrown away. Today it's going to an economizer to heat up the fresh air. Second, they planted a CHP, cogeneration, and there is also free of charge energy on jacket cooling. Again, this is now heating the air. Third of all the steam process, we gathered all the condensate together and produced flash steam. And again, free of charge, we keep on heating the air. Finally, a much smaller portion, they are using steam. What happened? The new process with 3 tons an hour needed 3,300 kilowatts, and now they are using 810 of them without any additional costs. And the air was entering between 3 to 23 degrees, and the humidity was something like 70–80%. So the drying process wasn't good enough. Today, out of the same process, now the air is reaching continuously 110 degrees, and the humidity is 0.5. So their drying process is enormously efficient now. At the end, they produce much more. So what happened? They invest 220,000 euro, and per year they are going to receive 200,000 euro back. 1.5 years. Again, what we have done is heat recovery. We just recovered the heat from somewhere else and used here. Another easy project can be using a high efficient boiler, a condensing boiler. What we do in the boilers are we just take fuel, mix with air and burn. We combust. At the end we have some losses and energy plus water. In the fuels of all kind of fossil fuels, in the flue gases of all kind of fossil fuels, there is water there. Certainly this water is in vapor form. Vapor means steam, steam means money. So you can just throw this away. That means from your chimney, you're going to lose energy because of temperature, because of wrong combustion, and also because of the vapor. So you can save the chimney losses caused by temperature. You can save the chimney losses caused by wrong combustion. in making really low flue gas temperatures and a good combustion. On the other side, you can save all the heat in this water vapor by let the flue gases condense. And through that, you can reach efficiencies above 100%, up to 110. Where is it coming from? For instance, as an example of natural gas, okay, an example of natural gas, this energy inside the water vapor is 11%. Can you imagine? And European standards were just disregarding this energy, saying this energy is not usable, we cannot use it, therefore we take it out and we say lower heating value. We were expecting that 1 cubic meter would give us 8,250 kilocalories. In the reality, there was more energy in it, but we were disregarding it. Whenever the condensing boiler started, it was just like a magic. The same 1 cubic meter we put in, but we receive more. And when you calculate, you are above 100%. That means in the reality, there is nothing above 100%. In the reality, we were just disregarding this energy. Now we are using it. Same process, everything is the same. I make the same heating, but saving a lot. So during combustion, by decreasing the chimney heat losses, I can save up to 7%. On the other side, by making a condensation, using a condensing boilers, I can save up to 10%. That means my same factory doing almost, not almost, exactly the same, is going to save continuously up to 17% or even more. And condensing boilers have large capacities also. Today you can find condensing boilers starting with 11 kilowatts up to 20,000 kilowatts, 20 megawatts. A city can be heated by using a condensing boiler also. Believe me, in Europe, in Germany, the market share of non-condensing boilers are almost disappearing because it is nonsense to use that. In Turkey, in Istanbul, floor standing boiler business is about to die, especially capacities up to 1,000 kilowatts. There is no reason that I'm going to put something because it's cheap and pay 20% more while my neighbor doing the same and paying 20% less. They are also saving a lot of space. So taking out and putting the same capacity in condensing is allowing you to save also space there. So condensing boilers are also better boilers. So if you are talking about a different system, a steam system maybe, boilers have continuous losses. This is the weird thing about it. So you save a lot and also you lose a lot at the same time. We can say boilers lose from the chimney generally, and boilers lose energy during operation, during cooling also. Cooling means the boiler is standing there, okay, and from the body we are just losing the energy. When the burner is on, we are calling it cooling. When the burner is off, the same energy we are calling standby. During standby, we lose energy. So in total, this energy amount can be 2%. So then comes the same question, if 2% is important or not. If yes, I have to find a way. On the other hand, chimney or combustion losses can be 7% or more. In order to save standby losses, the best way is I don't make any standby. If I don't stop, there won't be any standby losses. How can I prevent stopping? Very easy. Why is a boiler stopping? Demand is over or demand is low. So that boiler says, okay, I cannot do it anymore, I have to stop. So then a good way can be, even the demand is low, the boiler can follow this capacity. This we call modulation of capacity. So for many years we had on and off burners or two-stage burners. We could make only on, burner is on, off, or smaller capacity and one step more. Today, all the capacity long, we can decrease or increase our consumption. And what happens? At the end, my boiler is designed for peak load. If I cannot follow the lower loads, we all know peaks happen very seldom, but the lower loads happen more. For me, if I can modulate myself, as in my boiler, I am going to save energy. About to finish. 3 minutes. Because whenever I stop and start, I cause extra losses also. Every time when the burner starts, I throw away air, take the heat, throw to the chimney. Afterwards, I start combustion. And this starting period is very bad in efficiency. So I can save only by changing from on-off or two-stage to modulation 4–5% without doing anything else. And combustion-wise, it's also very important. So there are burners who can follow the draft of the chimney. So don't think the moment you start up a boiler, you make a setting and reach an efficiency, don't believe that it will remain till the end. Daily the efficiency will change. So that means in high capacities, if you can have burners with pneumatic mixing, frequency control or oxygen control, you are going to create extra savings. Because you keep combustion in a high level and the chimney losses will be low and low. Combined heat and power. Just one single thing about it. It's in the reality not an energy efficiency project. What we do is we just switch between the fuel types. Result is very well because mainly in the grids, the conversion ratio of oil to electric or gas to electric is lower than small size combined heat and power stations. One main mistake is done. Everybody thinks I have to put CHP for electricity. Theoretically, the first question for CHP is, do you need heat? If the answer is yes, second question is, do you need electricity? If this is also yes, then you can do it. Otherwise, if you have a CHP and you produce electricity but don't know what to do with the heat, then it is a wrong investment. So I just went again, in a plaster factory we made, so they invested 910,000 euro for CHP system, and annually they said 180,000 euro plus the extra electricity they produce, they sold annually with 250,000 euro. As you can see, the investment was based on heat, and the electricity was for them as a bonus. So out of this, they received their money back in 2.2 years. Everything is the same, you just switch from electricity to gas, and the result is very well. So there might be more topics, but the time is over now. But don't forget, so thermal insulation, compressed air, temperature settings, thermal storage. There are more topics about energy efficiency. As I said, electricity and heat shall be taken into consideration at the same time, otherwise the result will be limited. Thank you very much.